In this video, I focus on what real-time analysis reveals, not advanced configuration. This signal is real, but the spectrum analyzer doesn't always show it. In this video, I'll explain real-time spectrum analysis, what it is, why it matters, and what normal spectrum analyzers miss. Most spectrum analyzers work by sweeping. They look at one frequency range, then move to the next. If a signal happens between sweeps, the analyzer never sees it. Real-time spectrum analyzers work differently. They process data continuously without gaps. Here, actually, this is the Wi-Fi signal. Here, there's another Bluetooth signal. Actually, more Bluetooth signals here, but the spectrum analyzer cannot see it clearly. You see burst here. And here is the LTE signals. So you can always see, but unstable here. It's not clear here. We don't know it's two signals or one signal here. Total occupied some 40 megahertz bandwidth here. No gap means no missed signals within a defined bandwidth. Short signals are very common. Interference, hopping signals, digital bursts. If the signal is shorter than the sweep time, a normal spectrum analyzer may miss it completely. There's some signals here, but the spectrum analyzer misses them completely. For this signal, only see it once a while. RTSA, real-time spectrum analyzer, captures these signals because it processes data in real time. This is the RTSA view of the signals. Just now in the normal SA, some of the signals you can't see at all. But now with the RTSA, you can see all the signals quite clearly. RTSA usually adds new display types. The first is the waterfall display. Time flows downward. Frequency is horizontal. Short signals appear as bright lines. The higher the power, the warmer the color. Another useful view is density. It shows how often a signal appears at each frequency. Real signals look faint. Frequent signals look bright. Wi-Fi signal, LTE signals, two LTE signals. The brightest one is LTE signals. They are always there. Wi-Fi not as bright as LTE signals, but brighter than the Bluetooth signals. Let's look at the same signal. In normal spectrum analyzer mode, it appears sometimes or not at all. Now I turn on real-time spectrum analysis. The signal is clearly visible. Nothing changed in the signal, only how we measure it. RTSA does not mean unlimited bandwidth. There is always a real-time bandwidth limit. Signals outside this range are not processed in real time. Similar to normal spectrum analyzer, for real-time spectrum analyzer, the RBW makes a lot of difference. Now the RBW is 16.07 MHz. The signals you see here are not separate clearly. Let's reduce the RBW. Better, but still not good enough. Now you can see the signals are separated. But for these LTE signals are still not good enough. Let's reduce the RBW further. Now you see all the signals are separated, even the LTE signals close to each other. Let me switch on one of my phone's Bluetooth. You see the signal? On the other hand, FFT size controls frequency resolution. Large FFT gives more detail but uses more processing power. For beginners, start with default setting. Reduce bandwidth if needed. Focus on seeing the signal, not perfect resolution. RTSA is very useful for short burst, frequency hoppings, intermittent interference. RTSA is not always necessary for steady continuous signals. Simple amplitude measurements. Normal spectrum analysis is still useful. RTSA is an additional tool, not a replacement. Real-time spectrum analysis lets you see signals that normal sweeps miss. The key ideas are no sweep gaps, limited real-time bandwidth, powerful time-based displays. Please leave your comment for what you are interested on spectrum analyzer. We should discuss more on the normal spectrum analyzer, or we discuss more on the real-time spectrum analyzer. Thanks for watching.